We're going to go over the nomenclature and also drawing of organic structures and also how to calculate the IHD. Starting the first one here, give the UPAC names of these compounds. First thing that we do is to get to identify functional groups present. Here we've got an OH functional group, that is a hydroxyl, showing an alcohol. So to be able to name this one, we are going to start from where the alcohol is because it is the group of highest priority naming, so or counting. That will be position number one. This will be a group and we need to give us to give it a lower number, so this will be position number two. We'll not move in this direction counting because the group will receive a big number. And then 4, 5. Okay, so therefore to name this one at position number 2, we have got a group, but it's not an alkane, it's an alkene. So this is an alkene where 1, 2, 3, 4. An alkene with 4 carbons, but at position number 3, it has got a double bond. We always give it a lower number when you are giving a number to the double bond. And we are starting counting from where it is attached, not at the end here. So this is going to be 3-butyl. I'm putting it brackets. It was supposed to be butyl, but because it's an alkene, it's butynyl. And then at position number 1, we have got a function group of an alcohol, and it is in a cyclopentane. So I'll remove the E and put OL, so cyclopentane. So that is the name. And then the second one, identify the longest chain functional group of highest priority is here, so that will be position number 1. And we can't go and count in a circle, so we'll go in this direction. This will be position number 2, number 3, number 4. That means this is going to be a group. So at position number 1, we have got a group, and that is a cyclopentane, but as a group that will be cyclopentyl. And then at position and then this thing has got 4 carbons, that is a butane, but at position number 3 there is a double bond, so that will be 3-butane. At position number 1, we have got the alcohol functional group 1O, so that is going to be the name. And then to name this other one, we consider the functional groups present. We have got a chlorine, which is an halogen. We've got this, which is a ketone functional group. So a ketone has got higher priority than any other, which is here. So this will be position number 1. We go in the direction that will give lower numbers to other groups which are present. And this has got 1, 2, 3, 4 carbons. So 4 carbons, that is a but, and then you have got chloro. So B comes first in the alphabet, so we'll first name it. So that will be 4-butyl. And then at position number 3, we've got a chloro. And then this is a cyclo. So I can also state the position. At position number 1, we have got a cyclohexane. But it will not be just hexane because it's now a ketone, so hexanon. So that is going to be the name. Let's consider this. How do we get to name them? Again, we need to identify the functional groups present and then give them priority. So this one is the functional group of highest priority, which is a ketone. So how do we get to name it? We're going to name it in such a way that we're going to give a lower number to the ketone functional group, but also the group, this is going to act as a group. Okay, because the ketone has got highest priority to carry the parent name, but this will be a group, and we need to make sure that we give a group a lower number. So counting will start from here: carbon number 1, number 2, number 3, number 4. We'll not start counting from this direction because the group will receive a very big number. But also on the group, we can see this is carbon number 1. We're going to go in the direction. The group has also another group: carbon number 2, number 3, 4, 5, 6. So in here, we are first going to name on the parent chain, the group is at position number 1. So that will be 1. And then we are going to name now the group. What group is this? It is a cyclohexane. But it will not just be cyclohexane. For this cyclohexane at position number 3, there is a chlorine. So that will be 3-chloro. And then we say cyclohexane, but it's not hexane because it's a group, so it will be cyclohexyl. And then at position number 2 of the main chain, we have got a ketone, but there are 4 carbons. This is a butanone. So that is going to be the name 1,3-chlorocyclohexyl 2-butanone. Now let's also consider this one. Again, we need to consider the highest priority functional group, which is here. And so this will be position number 1. And then this will be position number 2, number 3, number 4, number 5, and number 6. Well, again here this will be position number 1 for the group, number 2, number 3, and number 4. So to be able to name this compound, we first need to consider the group, and this is going to be a group because we know that a ketone has got higher priority. So how are we going to get to name this compound? So at position number 3 of the many chain, we have got a group, and that group has got an halogen at the end. So I'll state the position of the halogen, that will be 4-chloro, and then I'll state the name of the group, that is butyl, because it has got 4 carbons. And then at position number 1, we have got a cyclohexane, but this is not an alkane, it's a ketone, so hexanone. And then for the other one here, well, what functional group is this? This is an ether functional group. So count the carbons this way and also count the carbons this way. 1, 2, 3, 4. I'll not count starting from this direction because this will be given position number 3. So to be able to name this one which is shorter is going to be considered as a group, and then the longer one is going to be considered as the parent chain for ethers. So for ethers, we don't know which one is going to be the many chain or not. All we consider is which one is shorter. So this one has got 2 carbons together with the oxygen is going to be called a methox. An eth. This was supposed to be ethane, but because of the oxygen it will be ethoxy. That is going to be the name. So how do we get to name it? So this is going to be ethoxy, but this group ethoxy is at which position of the main chain? It is at position number 2, so this will be 2-ethoxy, and then the main chain has got 4 carbons, that will be butane. It is a butane. That's the name. Let's also consider this one. Well, let's consider the groups which are present. We have got also an ether functional group. So to be able to name this one, now an ether functional group doesn't have that much priority. Actually, an alkane wins as a parent chain instead of this portion. So what you are going to do is you are going to consider which one is longer and which one is shorter to consider the parent name. So this side of the ether and this side of the ether. So which one is going to be the parent name and which one is not going to be? So to know that, we are going to consider the one which is longer or with a lot of carbon, that will be the parent name. So this will be the parent name 1, 2, 3, 4, and 5. And then this one has got only 1 carbon. So to be able to name this one, the first thing that we are going to do is we are going to consider this one, which we are going to consider as the parent name. We'll name this group which is there. At position number 3, we have got a bromine, and we name it as bromo. And then at position number 1 of this parent name, so this is going to be the parent name, but there are 2 groups there. A bromide is the group, and also this ether is a group to this alkane, which is in terms of a circle. So one bromo, I've named bromo because it comes first in the alphabet, and then I'll name the methoxy. So 1 methoxy. Now this is what? A cyclopentane. So that is the name. Let's also consider this other one. We have got the alcohol functional group of, obviously when you've got alcohol and we don't have a carboxylic acid, ester and also ketone and amide, then it has got high priority. This will be position number 1. Go in the direction that will give lower numbers to the groups which are present. So be position number 2, number 3, number 4, and number 5 there. So how are we going to get to name this one? So we're going to name first the groups. We have got a bromo and a methyl. Bromine comes first in the alphabet, so this will be 3 bromo, and then 2 methyl, and then at position number 1, that's where we've got the alcohol, so cyclopentano. So that is going to be the name. Well, let's get to name also this one. Identify the function groups present. We've got the alcohol, and you should always receive a lower number because it wins over this and over the double bond. So this will be position number 1, and then this will be position number 2, number 3, number 4, number 5, number 6. There's no carbon here because that's where there's attachment of bromine. So at position number 6 we have got a bromine, so that will be 6 bromo. And then, so for this one, we can see that at position number 4, I've got what? A double bond. So that will be 4, and this thing has got 6 carbons, 4 hexene. And then at position number 2, I've got an alcohol functional group. So that is going to be the name. And let's consider this other one. Well, we have got an ether there. We have got also a bromine. So the longest chain here is an alkene, and the ether and the bromine are the two groups which are present. So we're going to count in such a way that the double bond receives a lower number because it has got a higher priority than an ether or a bromine. So 1, 2, 3, 4, 5. Actually, this is just a group, so I'll not even talk about priority because we always consider the shorter part as a group. So this is going to be at position number 2, I've got a bromine, so 2 bromo. And then at position number 3, we have got a methoxy because of the oxygen. And then position number 1, that's where we've got a double bond, so 1 pentene. There are 5 carbons in this compound, so that will be the name. Now another question here, I want to give the skeletal or line formula of each of these. The first one is allyl benzyl ether. How are we able to give the skeletal name? So I can start with the benzyl, which is simply benzene. Benzene is an aromatic hydrocarbon. It has got 6 carbons. And the bonds inside are alternating. If we have got a double bond here, we are going to have another one there, another one here. At times you just see they've written a circle inside. That's the same because of resonance. So this is an ether. Now we want an allyl benzyl ether. Okay, so from ether, what does it mean? Because we're talking of an ether, that means we need to have an O bonded to a group this side and bonded to a group this side. So this group should be a benzyl and this group should be an allyl. Okay, so to be able to draw this, whenever we hear of allyl, when you're talking of a double bond, this carbon which is having a sp2 hybridization, which is direct bonded with a double bond to another carbon, is called a vinyl carbon. And the carbon that is attached to this carbon is the one which is called an allyl carbon. A carbon that is attached to a carbon that has got a double bond. So this is what we want to see. We have got a double bond here, so we should have another carbon which is here that is bonded direct to a carbon with a double bond, that is allyl. Now it should be ether, so this should be attached to an oxygen. There is no carbon here. Okay, now if that happens again, we need to have another group this side, because for an ether it should always be O and then R group, another R group that side. So again, this side it should also have a carbon that is bonded to a carbon with a double bond, because we also want to have an allyl. So like that, this carbon, there's a carbon at this point. There's no carbon here because that's where oxygen is being attached. Okay, should be bonded to another carbon which is here, and this carbon that has got a what? A double bond. So like that. So this is allyl benzyl ether. And let's consider now 3-methyl heptane 2,5 di 1. So just from the heptane, we know that there are 5 carbons in this compound, so we can draw that position number 1, 2, 3, 4, 5. And then at position number 3, we have got a methyl. So 1, 2, 3. So that's where we're going to have a methyl. There's a methyl here. And then at position number 2 and position number 5, we have got ketone functional groups. That's why the ending is 1. So position number 2 is here, a ketone, and position number 5 is there. 1, 2, 3, 4. That's position number 4. Position number 5 is here. And sorry, this one is heptane, not 5 carbons. It's 7 carbons. 5, 6, 7. I thought it's pentane. So that's heptane. Now let's consider C, which is 2-amino benzenitrile. Again, benz. First, I'll just draw the benzene molecule, which has got alternating double bonds inside. A double bond here, there, and also there. Now, at position number 2 of this one, we need to have an amino group. An amino group is simply NH2. So if we take this as position number 2, then either this one or this one can be position number 1. And the reason as to why that will happen is because the function group that is going to attach has got higher priority. That is why this will be considered position number 2, because the one that is going to be attached there is considered of higher priority, and that is a nitrile. And how is a nitrile functional group? A nitrile functional group is C triple bonded to a nitrogen. So that is a nitrile, like that. This is the function group from a nitrile. So this is 2-amino benzonitrile. Let's consider now D. We want M-dinitrobenzene. How do we get to draw that M-dinitrobenzene? So again, we'll simply draw a benzene first. It has got alternating bonds there, there, and also there. Now this is M. Whenever you hear of M in a benzene molecule, it should be 1, 3. So at this position, we are going to have a nitro. Nitro is NH2. Sorry, not NH2, that is amino. It's NO2. And then we can take this position also NO2. This is M dinitrobenzene. We also have P dinitrobenzene. This is 1, 4. We also have O, which is 1, 2. So this is how we can represent those.